All right, so now let's do our subderivatives for octahedral. So remember, octahedral, all of the positions, the axial and the equatorial, are equivalent. So it doesn't matter which one we pick. So I'm just gonna make this bottom guy a lone pair. So if he's a lone pair, what happens is the 4 that make my little square kind of start tilted up a little bit. So they just kind of go like, instead of being like this, they go whoop and go up a little bit. Because they gotta go away from that lone pair that's chilling there, okay? So instead of it being flat, they kind of just tilt up a little bit. So what this looks like is that it's gonna be a top with the 4 base, and it kind of looks like a pyramid a little bit. I'm gonna show you on here. So you've got 1, 2, 3, 4, 5, 6 things. So the parent geometry, the electron geometry is octahedral. But I made the bottom one a lone pair. And so what happens is these kind of tilt up a little bit. But what you can see here is that you've got a base, a square base, and the top is like a pyramid. So we actually call this one square pyramidal, because you got your square base and the top is a pyramid. Okay? So octahedral was those 6, the AX6, so I still have 6, but it's 5 bonds, 1 lone pair. And so we call this my square pyramid or square pyramidal, either one is fine. Okay? And so square pyramid, and then remember in an octahedral, in my perfect, everything was 90 degrees. So here, because that square kind of goes up a little bit, we get less than 90 degrees. Okay? So we get a slight deviation to perfect there. All right, so let's do the next one. So if I put the first lone pair on the bottom, the furthest away the lone pair could be is on the other side, which would be the top. So I put him on the top. Okay? And so what that means is these guys go straight down now. I mean straight back to where they were. So they're just going straight out. So they're not going up or down, because this guy's being pushed up by this guy's being pushed down, so he just stays in a perfect square. So we have a square, and it's in the same plane. They're all on the same level, so we call this one square planar. Just like the trigonal planar, where it was just a triangle, but this is a square. So square planar. So here, you still have 6, but it's 4 bonds and 2 lone pairs, and this one we call square planar. Okay. And in this one, because this is pushing up, this is pushing down, they don't deviate, that this actually ends up being exactly 90 degrees. So this one isn't less than or anything. This is going to end up being the ideal 90 degrees. So let me show you this one. So here you've got 1, 2, 3, 4, 5, 6 things attached, but two lone pairs, 4 bonds. So here's my ideal octahedral. I put one on top, put one on bottom. And so what ends up being is these guys end up not moving at all. So you just have my nice, perfect little square, and these are ideally 90 degrees. Okay? So that is all of my derivatives for all of my shapes. So now you know all of the electron geometries, and now you know all of the molecular geometries.